So thank you very much for coming. I'm Attila Mészáros, Principal Software Engineer at Red Hat. I'm creator and maintainer of Java Operator SDK, and going to talk about how to implement operators for Kubernetes in Java. First, just to understand what is the Kubernetes operator, we have to describe what are custom resources and how to extend Kubernetes API with custom resources. Then we are going to define the operator pattern, how does it look like, how the operators work, and then going to live code a simple operator just to show you the fundamental patterns and basically how to improve operators step by step and be more efficient and efficient. So extending Kubernetes API. Kubernetes from the beginning was kind of designed for extensibility. You probably assume that you know some built-in resources, like what is a pod, what is a deployment, that is kind of necessary for this talk. And there is a way to extend this, so extend the API server by defining your own custom types. This feature is called custom resources in Kubernetes. So in a nutshell, what you have to provide is a custom resource definition. What looks like this on the picture is basically if you apply such a resource, and this is really just a simple custom resource definition which says that we will have a new kind in Kubernetes called web page, and there are some additional informations how to rule out the singular if it's namespace code and the specs part, and some schema for the spec and the status that how the custom resources should look like. If you apply such a custom resource definition to Kubernetes, you think kubectl apply, then Kubernetes API is dynamically extended. That means from that point, you can use web pages as a new kind as you would use any other resource like these deployments or pods. So if you, from that point, you are able to apply these web pages. As told before, there is a spec part, which usually in Kubernetes, almost every object has the spec and the status. And for our sample and our live coding session, we will use this web page custom resource, which represents a static web page. So it's really applied, and from that point, Kubernetes will just will be aware of these custom resources. It won't do anything; it just will sit in the server. But this is kind of an abstraction about a problem. So by defining these custom resources, you can just abstract away on the Kubernetes API level some problem. Our problem will be how to serve these static web pages, which is a very simple example. But the same way would you do deploying like Kafka or other applications. So these are the custom resources. And as mentioned, spec is the specification, and status is just give you a observation how it was reconciled and how it the current status of these resources. So what are Kubernetes operators? Operators is basically a pattern for how to extend Kubernetes. It just uses Kubernetes operators use these custom resources and try to make it reconcile with the target state. What is a kind of very general definition. But it has these two parts, the custom resource and the controller. And the controller just checks which is these resources and try to implement the logic that will reconcile and make the world as we want to in the spec part. So more concretely, as this very skillful picture indicates, we have the Kubernetes API where these custom resources live, and we have the very nice CRUD API for that as for every Kubernetes resource. A controller watches the resources, checks the changes. This is basically a WebSocket. The controller connects to an API server. The API server then from that point sends the event in a WebSocket. The WebSocket is basically you just receive the event as a whole resource. So the payload of an event is just a whole resource. So you don't receive the modifications or things like that. It's a level-based approach. And the controller just does its logic, what we will basically implement and update the state on the cluster or outside the Kubernetes cluster. So just a few remarks. In the terms of a support for operators, Kubernetes basically ends with the API server. From that point, the implementation of the controller is just on you. So it's basically just a pod or process that tracks these custom resources and reconciles, as we described. This is absolutely the same in the Kubernetes itself. So the Kubernetes operators now work the same way. Maybe they are not running as a pod, but as the binary, but the same way they are just communicates with the Kubernetes. So with the pod, deployment, operator, controller, it's absolutely working the same as our custom operators will be. And just one more remark that usually people think that we are not managing resources inside the Kubernetes cluster, but it's a tendency to do and manage resources with Kubernetes operators outside the cluster. So it's projects like Crossplane, maybe that you know it's very, but basically manages like AWS resources or Azure resources on these public clouds using operators from Kubernetes. So to implement an operator, it's not necessarily a trivial thing, but there are frameworks that will move you to the right direction. And kind of a nicely solved problem, which are very common for every operator. Obviously, the most famous are the Go implementation of it, because Kubernetes is written in Go. So Go client, the controller runtime, and all about code generations tools are probably the most used. Then there is the Java stack. We use the Fabricate client, not the official one. We are very happy with that. But there are others like Cope for Python and Kubernetes for Rust. So it really doesn't matter what language you implement these operators. But please use a framework. And so just a few words about Java Operator SDK. It's really a mature framework now. We are developing it for more than 3 years. We try to be kind of a better is included. That means we out of the box provide some libraries, tools to make these operators happen. And we have a Quarkus extension to make it very easy to implement in Quarkus that also builds upon additional with features like code generation, live coding. And there is, of course, a Spring Boot starter. But we have also a plugin for the Go Operator SDK to scaffold the project, as you usually do with Go operators. Okay, so what we see is a tendency that people use the framework, which are people who are implementing the services itself. So usually this phrase, you build it, you run it, is somehow manifesting this that people like the Keycloak or Kafka developers, I want to also run or help to run their services on Kubernetes, and then they're usually implementing the operator in Java. Usually because they don't want to introduce another language to the project. They don't want to learn Go, but they just want to use Java as their favorite language. Okay, so our example will be very simple. It's just how to serve a static web page. So any user of the cluster will come, apply a web page custom resource, and in the background, the operator will create a config map, a deployment, and a service, where the config map will contain an HTML from the spec part and will be mounted to deployment, and an Nginx service will serve the static web page, and a service will expose it to the whole cluster. Okay, I'm already talking too much. I think we're going to now implement a naive implementation first. So I prepared the skeleton of the project upfront, so we don't take too much time. We have a standard, if you're a Java developer, Maven project with just 2 dependencies, the framework itself and the CRD generator that will come back later, and the class representation of the custom resource. So we had a web page, as mentioned, which has the spec and the status part. The spec contains the HTML as a string and the status, if it's just ready or not. So if I build this project with Maven, clean install, then we have this very nice dependency called CRD generator that will generate the custom resource definition for you. It's basically, you don't have to write by hand. If you have the class representation, then this custom resource definition is there for you, and if you change the classes, you just regenerate it as usual. we have just a main, because every application needs a main. This will be a pure Java project. And it's also very simply just we say that we want the operator using a Kubernetes client, and we register the controller. It's called reconciler, but because the terminology is like the logic that implements the reconciliation, it's called reconciler for a controller. And the reconciler is just very simple. It implements a reconcile interface, and you have to implement this one method for to implement the controller. And what you will see, the API is also simply just you receive always the new web page, some contextual information, and you instruct the framework how to update the web page, usually the status at the end of the reconciliation. And basically that's it. Now I start Minikube and going to create these free resources in reconciliation. So I have the client, I will create the config map, service, and deployment. So usually there is a notion called desired state. So in this case, desired config map based on the web page. And this desired config map we can create using the Java class model. Config map. Config map builder. So every Kubernetes resource has a name in its metadata. Check. Which we can borrow from the web page. So we can say that this config map will have the same name in the same namespace. And it needs the data, so we say that with data map of, we will pass the HTML to an index HTML, and the web page gets back get HTML. This normally would be enough, except that there is one tricky thing, that we add owner references. We won't go into the detail. Owner references in Kubernetes are used for garbage collection. If you delete the web page, you want to do all the resources which are related to be deleted. That's how Kubernetes objects usually work. So if we create such a resource, but we have to do it also for all the two other, the service and the deployment. So I won't really use a cheat sheet to get those, so we don't take too much time. But the principle is very, very similar. We have these free resources created using our model. Services. So notice that there is create or replace. If the resource is already created, it will override it. At the end, we probably just want to update the status. So we make sure that the status is there. And we say if these resources are created, it's ready. And just going to say that let's patch the status at the end. And we do one more thing. We reschedule the reconciliation. So we basically want that the reconciler will be executed every second. That's for the case when somebody would delete or modify a resource. We always want to make sure that the target resources are in the desired state. That's why we kind of do now, for now, this reschedule. And we can log some information that it was reconciled. Okay, let's apply these custom resource definitions to Minikube. So you use kubectl apply -f Okay, so the custom resource definition lives now on the cluster. We can run simply the operator locally because he automatically knows, since Minikube sets you the kube config, the client finds you the kube config locally. So it's very convenient to develop an operator just without deploying it as a pod in the cluster. So if I run this main, it will run the operator. We don't have a web page yet. We will apply a web page. And you will see that it will be reconciled every second. So we can check now on the cluster, probably all the resources are already created, config maps. And yeah, so they are there since it's reconciled. It's very straightforward. We can use Minikube to see the service LOPP, expose the service through an URL, and see that should already serve the web page. It's not as fancy as the metaverse presentations, but you get the point with a simple web page. And from this point, if you want to just change it and make some modifications to this custom resource, you can just do it, and the reconciler will do it in the background for you and change all the underlying resources. So this is a very simple operator. Usually this takes up to more than a minute, or sometimes more than a minute in Kubernetes, because how the config map mounts, but it will be eventually updated. So this is a very simple implementation of this operator. It just, we are creating the target resources, and that's it. And if we are replacing it every minute. So what are the problems with this? So first of all, we are doing unnecessary API calls to the Kubernetes API. Every time we reconcile, we try to replace the resource even if it doesn't change. And we do it a repeated way. So every second is probably a kind of an overhead. That should be probably a higher interval. But even then, the ideal state is just to reconcile when we know the sum of the resources are changed. The custom resource or the free resources that we manage. So, and that's kind of a fundamental logic behind operators, that we do it this way efficiently. So how to implement it with this correct behavior? That means we don't do API calls if it's not necessary, and we don't reconcile if it's not necessary. For that, we have to introduce a notion called event sources, or if you know informers in Kubernetes, it's basically informer event source in Java Operator SDK for Kubernetes objects. And it will do two things. Just as we are watching the custom resource with WebSocket, we are going to watch with WebSockets also the free resources, the config maps, deployment services. And informers will trigger the reconciliation if one of these resources are changed. And since it's a WebSocket, we always get the newest resource, we are safe to cache it. So we will always have the resource in the cache locally in memory. And yeah, and it will, the event source also will trigger the reconciliation, as I said. So if we have the resource already in memory, we can do a much more efficient reconciliation. We can just always compare the desired state with the actual state from a cache. Using this approach, basically no Kubernetes reconciliation or no API call will be done on the Kubernetes API. So even if you have hundreds of thousands of custom resources and start the operator, basically there will be no request to the API server. So that's the fundamental idea. I will just very quickly show it to you. How to do this using my cheat sheet. We have to implement an interface called event source initializer for the web page. And we just basically register 3 informer event sources. These are the event sources I talked about. one for config map, one for service, and one for deployment. Now, what is... Oh. Okay. And basically, these event sources will then do the caching and what we talked about. I don't know what's the problem here. Page. Okay. Okay, that should work. And now we can change the logic how to reconcile. Also, paste this. Explain it after. So we change every reconciliation of these resources this way. We provide an API to get the resource from the cache. The context get secondary resource will get you the related config map to the web page from the cache, from the event source. And we say that if this config map is present, it's an optional in Java, then we're going to match it if it's the same as the desired state. So, and if it's same, not the same, then we are going to replace it. If it's not there, not in the cache, then we are going to create it. And basically, the matching is very simple. It just say in the case of a config map that if the desired data is the same as actual data, then we are fine. We are not going to update the resource. We do repeat the same logic for every resource, the service and deployment. And also we can do the similar thing from the status. If the status is already set, we are not going to update it. We are going to just keep it. And then it's basically no additional API server calls to the Kubernetes API. Now, if I run this operator, it will not again reconcile periodically, just when something changed. So you can see it will reconcile, but no log message. If I changed the custom resource again, then it will just reconcile the config map. No, not other resources. Since it does not really change. The only thing that is we are using the HTML from the web page example is just in the config map. But for example, if I delete the service, then it will reconcile and will create the service. So that's the idea behind these efficient reconciliations, that you use these triggers and caches, so it's much more efficient to reconcile. That's in the nutshell. But you can probably recognize one thing, that we are doing lots of code duplication, like repeating the whole logic all over and over again. We are using kind of a low-level API to get the resource from the caches, do the same logic for every config map from a resource deployment. And we absolutely do the same thing that for informers. We are registering informers for all of them. So we thought this kind of screams for a higher level abstraction to abstract away this problem that we reconcile, match the resources. These are all generic subproblems. The one problem that is on one input that is really changing is the desired state. So we always have a type of a resource and its desired state. At the end, what happens, and the developer should care about, is just having this desired state somehow reconciled for you. And maybe it means some order. So for that reason, what Java Operator SDK tries to do is have this high-level concepts called dependent resources and workflows about that. It helps developers to implement this logic that you would do always all around. And I'm not going to change by hand the whole application, going to just very smartly check out the final solution. And this, what you will see, will be the absolutely equivalent what you did before. And basically, at the end, we get an empty reconciliation, and we say that we need a config map, a deployment, and service dependent resources. And these are just really classes which we extend from our abstractions. And you say that I want to have this desired state. So telling this to a framework using this high-level feature, it will do everything for you. This is absolutely the same, even more efficient and intelligent logic how to reconcile these resources. So basically, we have this low-level API and high-level API to do these, manage these resources. Usually, when you are implementing an operator, you don't care for Kubernetes resources only. They don't care about some ordering or some how these resources reconciled. Kubernetes doesn't work that way. But what we see is when we are having some resources like steps, when you create a pod, a service, and you want to make an API call that service to init some configuration, that's a typical use case when you want ordering in Kubernetes. And for that, we have a kind of there is a full-blown workflow language to depend on other resources. And so basically what we try to do is a high-level workflow language about these dependent resources. Okay. So this is what I wanted to show code-wise. There is much more to it. So this is the fundamental pattern to these operators, but there are these common sub-problems like rate limiting, how the finalizers, if you are ever in Kubernetes, metrics, and other notions handled. That's basically usually just a configuration or implementing other interface in Java 2. And yeah, if you're interested, just check out the samples, the docs, and also the Go Operator SDK has very good docs too, how to basically run your service from now on Kubernetes, especially if you are a Java developer. Okay, I was faster than expected, so we have a bunch of time for questions. I don't.
Oh, here is the first question. What about or you can read it.
Network dependencies between different. What are the efficient way of managing data, I guess, or network dependencies between different custom resources? That's a very good question. So, as you know, probably in Kubernetes, like deployment doesn't really manage pods directly. It manages a replica set. So under the hood, it creates other resources. So there is a tendency to create these custom resources also for different subproblems. And then you just break it down for reconcilers and controllers for those subproblems. And you just watch those resources the same way as you watch any other. So you are doing the same thing that we did with service or other resources, and watching those also and reconcile the same way. And so basically you just watch other custom resource within Informer. But that's a very common use case and very common problem. Is it clear or answers the question? Hopefully.
Do we have any other questions?
Thank you. Thank you very much. Yes.
Thanks. What about custom event resources? Can we also create program events be triggered the way we want? Or
you mean inside the reconcile or some other?
so we use the event resources to actually trigger a custom
Reconciliation. Yes.
So that event can be access it and program it?
No. So that's a very good question. That's a common mistake. So there are frameworks which allow it, but for example, the Go framework or the Java framework don't. It's because it's a best practice to access those events. So yes, there are events in the background which are intentionally hiding all those events. And I think maybe Python or other frameworks, I know there are frameworks which are expose those, and we were exposing it in V1 or something too. But no, that's a kind of a best practice to use those events in the reconciliation logic. It should be always level based. No, good question. It's so we use Fabricate client in Java, and it's very often we get this question that okay, but it's not Go. How do we keep up with all the Kubernetes versions that's coming out every 3 months or? And we are in very tight contact with the Fabricate team, and how it's done is basically we are generating the client from Go. So the Fabricate client and the Kubernetes client is implemented is we are just using those Go source codes and schemas and all other resources to generate the Fabricate client and do some other implementations. But it's always up to date. It's backwards compatible. That team is doing a really extremely good job with this. So, and there is also the Go client has all kinds of other features like informers and leader election. Everything like these functions are also in the Java client. So it's almost one-to-one to the Go client. It's really impressive how they are doing this.
There is one more.
Ideally, so operators are the native way to run your application and on Kubernetes. So usually you could ask what is the difference between a Helm deployment or an operator. The Helm just creates the resources. There is no watching, there is no reacting, and it's very limited. So it's here you can write the Java code and usually do some migrations, backups for database. Any logic that you can imagine, you can write as an operator. You are very limited with other solutions, so very limited for Helm charts, which are just able to just create some Kubernetes resources. So I would say that most of if you don't have a very simple application that requires some logic, it should be an operator. But there is quite a discussion around this. If you probably just apply a Helm chart or apply some resources in Kubernetes and somebody deletes it or somehow gets modified, it's no automatic repair or self-healing in that. For that you need an operator, not a Helm chart. No other questions then?
So if there are some other questions. And 3, 2, 1.
Okay, thank you very much for listening.
Thank you, Attila.